Hi everyone. This video is going to introduce some important things that you need to know about rational functions. So first important question, what is a rational function? Rational function is the quotient of two polynomials, p of x divided by q of x. Likely they just used p for polynomial and then q because q is the letter that comes after p. These functions are continuous at x values where q of x equals 0. In other words, if we set the denominator equal to 0, we'll be able to find and solve for all of the x values where the function is discontinuous. Let's look at some examples. If you can't see where these numbers are coming from, I'll explain it more at the end of the video. When we look at this function, we see that this function will be undefined at x equals 1 and x equals -3. These are restrictions because they tell you what values of x you are not allowed to use. Substituting x equals 1 or x equals -3 into the function will cause you to divide by 0, and thus the y value of the function would be undefined. Now we can use this information to write the domain. Because rational functions are obtained by dividing polynomials, and polynomials all have domains from -infinity to +infinity, when we divide them, they're still going to have a domain from -infinity to +infinity, except we're going to have to exclude the restrictions. Therefore, the domain of this function is -infinity to -3, union -3 to +1, union +1 to +infinity. Notice that we use open brackets for x equals -3 and x equals +1 because those values are not included. We can put in any number infinitely close to these, such as -2.999999 blah 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 blah, or -3.000000 blah 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 1, but just not -3. For this function, we see that x cannot equal square root of 5 or negative square root of 5. Therefore, the domain is -infinity to negative square root of 5, union negative square root of 5 to positive square root of 5, union positive square root of 5 to +infinity. Again, notice open brackets on negative square root of 5 and positive square root of 5 because those x values are not included in the domain. This polynomial has no restrictions. There is no x value that makes the denominator 0. Yeah, I know you could use imaginary numbers, but we don't worry about those anymore. Therefore, this function's domain is from -infinity to +infinity. Lastly, we're going to talk about asymptotes. Asymptotes are lines or curves that the graph of a function approaches but does not actually reach. The part about asymptotes being curves, you don't have to worry about until next year in pre-calc. All of the asymptotes that we look at this year will be lines. Asymptotes can be vertical, horizontal, or oblique. Horizontal asymptotes we write with the equation of a horizontal line. So for example, like y equals 1. Vertical asymptotes we write with the equation of a vertical line. So for example, you could have one like x equals +2 or x equals negative 2. Notice that when I draw the actual curve onto the graph, the lines can get close to the asymptotes, but they don't reach them. Also notice that the horizontal asymptotes, this is only happening at x equals negative infinity and x equals positive infinity, that the curves are approaching the asymptotes. A final type of asymptote is an oblique asymptote, which just means not horizontal or vertical. For example, this oblique line is an oblique asymptote. It's slanted, it's not vertical or horizontal. And as x goes to negative infinity or x goes to positive infinity, the curve approaches the green line. These you won't really work with much until next year in pre-calculus, but at least for now you need to know that they exist. So that's all the important stuff that you need to know about rational functions for now. So hopefully when we start doing things in class, you'll be able to start using these words correctly and use them to really clearly communicate with your classmates what's happening with these different types of functions. Okay, so if you have no idea where the restrictions and domains came from some of the earlier slides, I'm going to explain that a little more clearly in this slide. Anytime we want to find a discontinuity, we need to figure out where the denominator is equal to 0, and so we can set up an equation. For this one, I take the denominator, x minus 1 quantity, and then quantity x plus 3. By setting it equal to 0, I notice that it's factored, so I can use the zero product rule to find that x equals 1 and x equals negative 3 are restricted values, so that's what x is not allowed to equal. For the second function, I can take the denominator, x squared minus 5, and set it equal to 0. By adding 5 to both sides, I can then take the square root of both sides, so I know that x cannot equal positive or negative square root of 5. This last one, if we take the denominator x squared plus 1 and set it equal to 0, by subtracting 1 from both sides, I notice that my answers to this are going to be imaginary, so I don't have to worry about them.